In this lesson, we're going to talk about surface area. Surface area is the total area of the surface of a three-dimensional object. I have a great picture here below of a rectangular prism's surface area. You can see that the surface area is all of the different surfaces of the object. So this is showing you the top surface, the front surface, the left, the bottom, the back, and the right. If we were to take each one of those 6 surfaces and add them together, we would get the total surface area of the prism. Another way to look at it is looking at it as a net. Now, a net is what this little object is here to the bottom right. If we were to unravel a prism, basically what I mean is taking a cereal box and basically breaking it apart so that you can see all of its surfaces. That's what it would look like. It would look like this below. Now, when we're talking about surface area, we're not talking about what's filling up the figure. So we're not figuring out how much water or how much sand can fill it up. We're just looking at the different surfaces or just the outer edge and the calculation of that area. If you remember from a couple sections ago, we just talked about area. Remember when we would talk about painting a wall and the area of the wall? Well, now we're just taking the area of multiple walls and we're adding them together. So what we need to know is we need to know the formula. Again, you're going to want to have your formula sheet and a calculator for this section. You can see that the formula is up here to the right. We've already used this picture when talking about volume, but in these problems, we're no longer going to be using the volume formula. We're going to be using the SA, which is surface area. What it represents is it says surface area is 2LW plus 2LH plus 2WH. It looks complicated, but really we already know what these mean. L is always going to be our length, width is going to be our W is going to be our width, and H is going to be our height. So we're going to take those 3 different dimensions and just plug them right into the formula. All right, let me show you how this is done. Here I have 2 rectangular prisms, and I'm going to go ahead and calculate the surface area. If you wanted to, you could also calculate the volume, but we're not going to go ahead and do that in this lesson. We're just going to talk about surface area. All right, so let's use my formula. I'm going to go ahead and write my formula down first. So I'm going to write SA is equal to 2LW plus 2LH plus 2WH. And now let's go ahead up into our picture and let's actually label our rectangular prism. All right, let's say that the length is going to be 10. And let's say the width is going to be 5. And then let's say our height is 2. I always like to start by labeling them because then I can just simply take the numbers and plug them into my formula. So let's go ahead and do that. Notice how I'm continuing to write SA down my page. Now this is where you need to be very, very, very careful. You need to make sure you put the correct numbers into the correct variables. So I'm going to say 2 times my length, which is 10, times my width, which is 5, plus 2 times my length, which is 10, times my height, which is 2, plus 2 times my width, which is 5, and my height, which is 2. What that has done is it's created 3 different chunks. You can see that the first chunk is right here, the second chunk is here, and the third chunk is here. Let's go ahead and multiply these 3 chunks. So I have my surface area is equal to 2 times 10 times 5. Well, 2 times 10 is 20, and 20 times 5, well, that's going to give us 100. So this whole chunk is going to be 100. Let's go ahead and carry down my plus sign. And let's do the second chunk. 2 times 10 is 20, and 20 times 2 is 40. I'm going to carry down my plus sign and do my last chunk. 2 times 5 is 10, and 10 times 2 is 20. So now that I have my 3 chunks, let's just go ahead and simply add them together. 100 plus 40 is 140, plus 20 is 160. All right. Again, just like we talked about with volume. Now, when we're talking about surface area, as I said before, remember when we talked about area, we talked about just the area of a wall, which is a two-dimensional figure. What we're really doing here is just taking the area of multiple surfaces. So we're not taking, we're not looking, we want to make sure that we square everything is what I'm basically trying to say. We're not cubing it because we're not looking at the volume. So the units here are going to be centimeters squared. Anything with the word area in it is always going to be squared. So the surface area of this rectangular prism is going to be 160 centimeters squared. Okay, let's go ahead and look at another one. I have another rectangular prism, so I'm going to go ahead and first label my sides here. I'm going to label, let's go ahead and call 20 my length, and then we'll call 8 my width, and we'll call 16 my height. I like to start there because I'm just going to take those numbers and put them into my formula. So here's my formula. SA is equal to 2LW plus 2LH plus 2WH. Now let's go ahead and plug those numbers right in. Surface area equals 2 times my length, which is 20, times my width, which is 8, plus 2 times my length again, which is 20, times my height, which is 16, plus 2 times my width, which is 8, and my height, which is 16. Again, that created those nice 3 chunks that we're going to go ahead and multiply and then add them together. So my surface area is equal to, you might need a calculator for this one, 2 times 20 is 40, times 8 is going to give me 320. So it's a little bit of a bigger number. Carry down my plus sign. 2 times 20 times 16 is going to give me 640. Carry down my plus sign. And then 2 times 8 times 16, that's going to give me 256. The last step is to simply add them all together. Feel free to use your calculator. 320 plus 640 will give us 960 plus 256, which is 1,216. And our units will be centimeters squared. All right, so the surface area of this prism is 1,216 centimeters squared. Okay, now let's go ahead and see if we can take a look at this example of a cylindrical prism. Now that we've talked about the surface area of a rectangular prism, now we want to figure out how to find the surface area of a cylinder. So this is like basically taking a soda can and figuring out how much area is covering the surface of that can. So you can see here that we have a different formula that we're using. And we've looked at this picture before when we talked about volume. But this time we're going to, again, be using the surface area formula, which is kind of a little bit more complicated. Well, not complicated, but a little bit more complex. The formula is going to be surface area equals 2 pi r squared plus 2 pi rh. So what we need to know from this picture is we need to know the radius and we need to know the height. So before we go into calculating, let's go ahead and see what the net looks like. If you look at the picture down here at the bottom, you can see that the net looks different than the rectangular prism's net. This just has a rectangle with 2 circles, the one being the top circle and then the other being the bottom circle of the cylinder. So that's what the net looks like whenever you unravel that surface area. All right, let's go ahead and see if we can go ahead and solve some of these. So we're going to need our formula. So I'm going to go ahead and write that down first. So I'm going to say surface area is equal to 2 pi r squared plus 2 pi r h. Let's go ahead and label our pieces. So you can see here that we have, actually it's already labeled for us, that's nice. The radius is going to be 3 inches and then the height is going to be 10 inches. So let's go ahead and take that information and substitute it into the variables. So we have the surface area is equal to 2. Now, if you remember, we take our pi and we're going to write 3.14. So I'm actually going to use a parenthesis to separate my 3.14. And then my radius, which is going to be 3. squared plus 2 times 3.14 times my radius times my height. All I did was substitute those numbers in. Now I'm going to calculate. Now the biggest, area that is kind of easy to make a mistake in is the order of operations here. Just remember that this needs to come before anything else in this first chunk. So I'm going to do my 3 squared first. I'm actually going to write down this step so that you can see it. So I'm going to take 2 times 3.14 times 9. I'm going to write that down. Plus, and then I'm just going to rewrite everything. I wanted to write that step down because it's probably the most common area to make a mistake. Now let's go ahead and look at these 2 chunks. All I want to do is multiply these 2 chunks together and then simply add them. So this one's going to be 2 times 3.14 times 9. And you can do that right in your calculator. That's going to give us a decimal of 56.52. Carry down my plus sign. Now the next one's going to be 2 times 3.14 times 3 times 10. That's going to give me 188.4. And to finish this problem off, I'm just going to go ahead and add these together. 56.52 plus 188.4 right in the calculator. That's going to give me 244.92, and that's going to be inches squared because surface area is always squared. All right, you can see that it's a little bit more complex than the rectangular prism. So let's go ahead and try another one just for practice. I'm going to start with my formula. So my surface area equals 2 pi r squared plus 2 pi r h. I'm going to go ahead and label everything, and in our case it is, but you can see here that I'm given a diameter. I don't want the diameter because my formula is using radius. So I need to change my diameter to a radius. My radius is going to be half of the diameter, so it's going to be 5 centimeters. And then, of course, I have my height. Even though doesn't look like it's, from the ground to the sky, you can see that it's on its side here, and that's still going to represent our height. So my surface area is going to equal 2 times 3.14 times my radius, which is 5 squared, 5, and then square it, plus 2 times 3.14 times my radius again, which is 5, times my height, which is 15. And I'm going to go ahead and simplify this, and I'm going to do that extra step in between because it's very forgettable. Be careful here because 5 squared is 25. 5 times 5 is 25. Be careful not to write a 10. And I'm just going to go ahead and write this out again. I know it might be kind of annoying to do so, but it's worth it to not make that mistake. So I'm just going to rewrite the whole thing out. And now I'm going to go ahead and I'm going to chunk it. And the chunks are separated by the addition sign. So I'm going to multiply 2 times my 3.14. And I'm going to multiply that again by 25. And that chunk is going to end up being 157. Carry down my plus sign. And now I'm going to do 2 times 3.14 times 5 times 15. And that's going to give me 471. And to finish this off, I'm going to go ahead and add those, and that's going to give me a surface area of 628 centimeters squared. Okay, now that we know how to do the calculation using the formulas, now I want to move into some applications. I have 3 application problems for you here. Now, this one's a really cool one because it looks really complex. It says the picture is the net of a rectangular prism. Determine the surface area of the prism. Well, earlier on we talked about the idea of a net, right? That's basically when you take the cereal box and you unravel it, and what do you have? Well, this is what we have here. So what we want to do is figure out what the surface area of this is. Now, I could take each piece individually. Let me show you what I mean. I could take the area of this piece, and 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 this piece. And I could find the area of each one of those individually and add them up. I could absolutely do that. But instead, I'm going to go ahead and use the information that they give me to see if I can just calculate it pretty simply. So you can see here that I have a lot of the same numbers. I have a lot of 8s, I have a lot of 5s, and I have a lot of 3s. You can see first that the 8 inches looks like a long side length, right? All of the 8s I represented in blue. Let's go ahead and call that my length. And I'm going to go ahead and grab a different color here. I'm going to grab my red. And let's go ahead and do all the side lengths that are 5. You can see that they're across from each other. And you can see that they're all the same length of 5. There we go. So let's go ahead and call that let's go ahead and call that our height. And then the last one, I'm going to go ahead and label them in green, is a 3. You guessed it. We're going to go ahead and call the 3 the width. So we have a length, we have a width, and we have a height. Okay, now let's go back to the problem. Let's go ahead and use our surface area formula. And if you need to grab that, you can grab that right off of your formula sheet. So I'm going to say surface area is equal to, ready? 2 length times width plus 2 times length times height plus 2 times width times height. Now let's go ahead and plug in the numbers. My surface area equals 2 times my length, which I labeled 8, and my width, which I labeled 3, plus 2 times my length of 8, and my height of 5, plus 2 times my width of 3, and my height of 5. Once I put those all in there, you can see that it's broken down into my 3 chunks. Let's go ahead and simplify them now. I have 2 times 8 times 3. That's going to give me 48. Bring down my plus sign. We have 2 times 8 times 5. That's going to give me 80. Plus 2 times 3 times 5 again, 30. Add them all up. 48 plus 80 plus 30 is going to give me a surface area of 158 inches squared, since I'm talking about surface area. So we could have found the area of each one of those pieces individually, but I think that would have been a little bit more time consuming, to be honest with you. So we could always use our formula here instead. Okay, here's another one. Another application. A cosmetic company that makes small cylindrical bars of soap wraps the bars in plastic prior to shipping. Find the surface area that will need to be covered by plastic if the diameter is 5 centimeters and the height is 2 centimeters. So, all right, the first thing we know here is that it's a cylinder. So we're going to be using that formula for cylinder. So you can grab your formula sheet, and we're going to use surface area equals 2 pi r squared plus 2 pi r h, which is our height. Now, let's look at the information that they give us. They give us the diameter is 5 centimeters. Well, remember, there is no D in our formula. There's an R. So we need to take 5 centimeters and we need to split it in half. So if we split that in half, that's going to give us a radius of 2.5 centimeters. So I'm just going to go ahead and cancel out that 5, and I'm going to be working with my new radius. And it gives us a height of 2 centimeters, so we can use the 2 centimeters. Let's go ahead and plug it into our formula. Surface area equals 2 times 3.14 times my radius, which is 2.5 squared, plus 2 times 3.14 times 2.5 times my height of 2. Now, when you're working with all these decimals, you need to be really, really, really careful that you don't make any mistakes with them. So again, just like before, we're going to start with our exponents. So I'm going to rewrite the whole thing just because it's worth it to me not to make that mistake. So when I take 2.5 and square it, it's basically saying 2.5 times 2.5, and that's going to give us 6.25. Plus, and then I'm just going to go ahead and carry everything down. Now, this is going to take a little bit of time. Go ahead and feel free to pause the video here and work these decimals in your calculator. But I'm going to do 2 times 3.14 times 6.25. That's going to give me a surface area of 39.25 on that little section. Now I'm going to go ahead and figure out the other section. 2 times 3.14 times 2.5 times 2. And if I'm going too fast here, please feel free to just pause the video, do the calculation, and then check them with me. All right, that's going to end up being 31.4. Now, to finish it off, let's go ahead and add them together. So I've got 39.25 plus 31.4. Surface area is going to be 70.65, and I'm working with centimeters squared. So that's how many centimeters squared that this cosmetic company is going to need of that plastic wrap to wrap around each of those bars of soap. All right, I've got one more application problem for you. The 2 juice box containers below hold the same amount of juice. Which container would be less expensive to manufacture if the cost of the material to make them was the same? So we're looking at the material on the outside of each container. So we're looking at the can, which is aluminum, and then we're looking at the box, which is cardboard. So we need to figure out the surface area of each of these figures, because that's going to tell us which has the most surface area, which is going to tell us which one was more expensive to manufacture. Okay, so let's just go ahead and look at the can first. The can seems to be a cylindrical prism, so we're going to use the formula for a cylinder. So we have our surface area. Let's go ahead and write it out. 2 pi r squared plus 2 pi r h. If we look at our dimensions here, you can see that we're given a height of 9 and we're given a diameter of 6, which means we need to grab the radius. The radius is going to be 6 divided by 2, which is 3. Okay, now let's go ahead and plug it in. Surface area equals 2 times 3.14 times 3 squared plus 2 times 3.14 times 3 times 9. Feel free, again, to pause the video and see what you can do with this problem. I'm going to go ahead and start with my exponent. 3 squared is 9, so I'm going to go ahead and write that whole step again, just because I find it to be very important to do so. And I'm going to write everything out. Now let's go ahead and break it into our chunks. And let's go ahead and calculate. The first chunk, 2 times 3.14 times 9 is going to give me 56.52. Plus my second chunk, 2 times 3.14 times 3 times 9. That's going to give me 169.56. Let's go ahead and add those two together, and that's going to give us our surface area of the can. 56.52 plus 169.56. That's going to give us 226.08, and that's going to be centimeters squared. Okay, so that's going to be the surface area of our can. Now, let's go find the surface area of the box. So I'm going to write box right here. And we need a new formula, don't we? Because the box is a rectangular prism. So I need to go grab my rectangular prism formula. That's going to be 2LW plus 2LH plus 2WH. I'm going to go ahead and label it. My length looks like it's going to be this guy down here, 5 centimeters. My width is 5 centimeters, and my height is 9 centimeters. Let's go ahead and plug it into our formula. 2 times 5 times 5 plus 2 times 5 times 9 plus 2 times 5 times 9. We have our 3 chunks, so let's go ahead and calculate each of the 3 chunks. 2 times 5 times 5, that's going to give us 50. 2 times 5 times 9 is going to give us 90. 2 times 5 times 9 is going to give us 90 again. All right, let's go ahead and add up our final surface areas here. 50 plus 90 plus 90. That's going to give us 230 centimeters squared. All right, let's look at the two surface areas now. I've got my surface area of my can and surface area of my box. You can see that the box has more surface area, which means, looking back at the question here, if the cost of the material was the same, that's what it says. So no matter if you were working with the aluminum or the cardboard, it was the same price. You can see that the box is going to have more surface area, which means that the box is going to be more expensive. So to answer this question, the can is going to be the least expensive out of these two options. Okay, so those were 3 application problems for you of surface area, and that brings us to the end of our lesson.